Hi class. So what we're going to look at now is limiting reagents. So limiting reagents is when we are given the grams of both reactants, right? Or if we even have more reactants, if we're given more than one. So in this example, we're looking at the combustion of ethanol and oxygen, and we're given the grams of both. And so one thing I do want to point out before we start looking at this is don't just assume that the smaller one is always going to be the limiting reagent, because it really depends on the molecular weight of the compound as well. So we have to actually work through each of these. So what we're going to do is actually solve for each one. So how many grams of CO2, so carbon dioxide, would we get with 12 grams of ethanol? And then we'll go back and do the process again with 64 grams of oxygen and see how many grams of carbon dioxide it produces. And whichever is the smallest will be our limiting reagent, and that will be our theoretical yield. All right, so let's just jump right into it. As we're looking at this, one thing I want to keep in mind is that we always are going through this process. We're going grams to moles to moles to grams. And so if you remember, this grams over here is our starting material, still our starting material of moles, and then we have to have that conversion factor to get this to our product, and then our product of grams. And I just like to always write this out because I feel like it gives us a way to really keep track of what are we trying to get to in that next step. And as we go through the steps, we'll write down the conversion so we can kind of keep it fresh in our mind. But if you can kind of commit this game plan to memory, it'll help you if you kind of get stuck. And generally, if you're trying to solve from one unit of a item in the balanced equation to another, it's usually going to go through moles. Not always, but it's a safe bet that that's a good way to go if you're trying to help yourself out. All right, so let's give this a try. So let's start with our 12 grams of ethanol. So we're going to take our ethanol, and it's C2H6 oxygen. And now what we want to get is the molecular weight. So the molecular weight of this compound we can get by adding up the carbons, right? So each carbon is 12, so we're going to do times 2. Each hydrogen is 1 times 6, and then we have 1 oxygen at 16 times 1. Right? And so if we add all of that up, we can see that we get 46 grams per 1 mole of ethanol. Right? And so what that tells us is we want to divide by the molecular weight to get to moles. Right? And we want to divide so that we get moles on top, right? Because that's going to allow our grams to cancel out. All right, the next thing we want to do is our conversion. And so remember, if there's no number here, we're going to assume it's 1. Over here we have 3, 2, and 3. So the way this is going to work is you always want to put the number on top of what you're trying to get to. So we're trying to get to product, right? And we have 2 products, but here specifically, it's asking for carbon dioxide. So we want to put the coefficient of carbon dioxide on the top. So let's do that. And then we're going to put what we had for our reagent. So the starting material we're starting with is ethanol. So we come over here and it's a 1. So we'll put 1 mole. All right. Then the next thing is here we used our mole ratio. Is we're going to use molecular weight again. And now we want to use the molecular weight of our CO2. So just like we did over here, we have 1 carbon, 2 oxygens. If we add all of that up, we can get the molecular weight of our product, and that's what we can put in this other spot here. So we'll do the same as before. We'll put 44 grams of CO2 over 1 mole of CO2. All right, and so remember that this 44 we got by adding up the atoms in each of our products. All right, and so if we punch that into our calculator, we should get 22.95 grams of carbon dioxide. All right, and I didn't pay attention to significant units. I just wanted to make sure we're getting the math right. All right, so now that's how much we get if we use ethanol as our limiting reagent. Now let's do this whole process over, and I know it's tedious, so I apologize, but this is the best way to make sure that you're always getting the right answer. We can take our 64 grams of oxygen, right? And remember, we got the 64 grams from up here. If you kind of scroll back up to the top, it told us we had 64 grams of oxygen, so that's where we're getting this from. Now, we're going to do the same thing. We're going to divide it by the molecular weight. But remember, we're always dividing it by the molecular weight of the compound we're working with. So for oxygen, each oxygen is 16, and there's 2 of them. So we'll put 32 grams here of O2. And now we need the mole ratio. The mole ratio in this case is 3 for oxygen and 2 for carbon dioxide. And remember, we always put what we're trying to get to on top. So the 2 moles of CO2 will still be on the top like the previous one. And this time on the bottom, we're going to take this 3 moles of O2. All right, on the other side, we're still going to get to the same product. So we're still looking at grams of CO2. So we'll put that molecular weight because that didn't change per 1 mole. All right. And now we should be in good shape, but what we can do, and we didn't do this on the top one, but I think it's a good practice, is always go through and cancel out your units. So if we're going to go through this, our units of grams should cancel out. Perfect. Here was moles of O2, so our moles cancel out. Now here it's moles of CO2. They cancel out. And now at the end, we're going to be left with grams of CO2. And so if we punch this into our calculator, 58.66 grams of CO2. Let's do the same on the top just to double check our answer. Our grams of ethanol cancel out. Then our moles cancel out. Our moles of CO2 cancel out. And we're left with grams of CO2. All right, now we've solved for both using ethanol as our limiting reagent and using oxygen as our limiting reagent. We want to see whichever one gives us the smallest amount. And in this case, it's the top. All right. So our ethanol would be our limiting reagent, and our theoretical yield would be 22.95 grams. All right. So I know it seems a little tedious, but the best way to do this is just work out both of them and see which one of these is going to give you the smallest amount. All right. And so I think if you're really careful about canceling out your units and really making sure you're keeping track of all of your compounds in terms of going from grams to moles of product, to our grams of product, you'll be in good shape. All right, I hope this was helpful, class.